Section 4.6 is our last section that covers the shortcuts to prove that two triangles are congruent. And they are ASA for angle side angle and angle side, which is AAS. So the first one is a postulate, angle side angle. It states if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So just like the other shortcuts, if I have angle side angle, I have two congruent triangles. The next is actually a theorem, and that's for angle side. It states if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So again, it has to be the corresponding non-included side. So when you write this in your notes, I'd make sure that you emphasize that it has to be the corresponding non-included side. So again, it would have to be angle side, angle side. And if you have that situation, then you would have two congruent triangles. For the rest of this section, you'll see a couple proofs where we're going to prove that two triangles are congruent using either angle side angle or angle side. Example number 1, can the triangles be proven congruent with the information given in the triangle? If so, state the postulate or theorem you would use. So when I look at part A, I see I have two triangles right here. I have one angle is congruent to this angle, so I have one pair of congruent angles. I have a second pair of congruent angles, and this side corresponds to this side, but it is not the included side. The included side would be if this side was congruent to this side, since it's in between the two pairs of congruent angles. But again, we don't have that situation. We have a pair of non-included sides that are corresponding to each other that are congruent. So in this case, I have angle side. So I could prove these two triangles congruent by angle side. Now looking at part B, I see two triangles, and I have this angle is congruent to this angle, these two angles are congruent, and these two angles are congruent. I do not have congruent sides though. I do know that from here to here would be congruent to itself, but I don't know the entire sides are congruent to each other. I don't have any sides congruent, and I just have three pairs of angles that are congruent. I do not have a shortcut that is angle, so therefore I cannot prove that these two triangles are congruent. And part C, I have a pair of congruent angles, a second pair of congruent angles, and the side in between them, so the included sides are congruent. So I can prove that these two triangles are congruent by angle side angle, which again is different than angle side, since the side that was congruent were in between the two angles that were congruent. Let's move on to a proof. So example number 2, we are given that angle C and angle F are congruent. If I wasn't already given this in my diagram, I would make sure I mark that angle C and angle F are congruent. Again, the visual of seeing these things, as we've been talking about in class, will really help you in the end as you mark things on your diagram. I'm also given that segment AC is congruent to segment DF. That's not marked in my diagram, so I'm going to go ahead and do that. So AC is congruent to DF. I'm also told that segment AB is perpendicular to segment BC. Remember, this symbol means perpendicular. And I'm also told that segment DE is perpendicular to EF, because remember, this means perpendicular. I mark that on my diagram by showing that the two segments are forming a right angle. And again, that's already marked in my diagram for me. And we're asked to prove that triangle ABC is congruent to triangle DEF. On first instinct here, I think that I could use hypotenuse leg since I technically have right triangles. However, I'm only given that the hypotenuses are congruent to each other. And there's nothing within my given information that I can use in order to prove that one of the legs are congruent to each other. So I know hypotenuse leg is off the table. So I got to find a different shortcut to prove that these two triangles are congruent. So let's start with our given. So I'm going to write down that angle C is congruent to angle F. And I know this because it was given. Next, I'm going to write down that segment AC is congruent to segment DF. also because it was given. I'm going to combine the next two, that segment AB is perpendicular to BC and segment DE is perpendicular to EF, just because they are basically saying the same thing, and that reason would also be given. Of course, I always have the option of grouping all of these together and just putting them into one statement with one reason of given, and it really doesn't matter. I just tend to group things that have similar things in them. So by the fact that I know that segment AB is perpendicular to segment BC and segment DE is perpendicular to segment EF, that means that I know that angles B and E are right angles, because that's the definition of what perpendicular means. So I'm going to write down for my next statement, angle B and angle E are right angles. And again, my reason would be the definition of what perpendicular lines are. So again, angle B and angle E are right angles, and that's the definition of perpendicular lines. Because I know angle B and angle E are right angles, I know that angle B is congruent to angle E, because I know all right angles are congruent. That is the right angle congruence theorem. So now looking at my diagram, now that I've stated that angle B is congruent to angle E, I now have angle, angle, side. So I can now state that triangle ABC is congruent to triangle DEF because of angle, angle, side. Again, that's different than angle, side angle, since the side was not included between the two angles that we had as congruent. This is the end of the proof, so I put the 2 tick marks to indicate that. Example number 3, we see a proof, and this proof is probably one of the toughest ones we're going to see so far out of the whole year. So the first thing that we're given is angle CBF is congruent to angle CDF, and segment BF is congruent to FD. I find it extremely helpful to mark these things in the diagram as we go. And I think it would be especially helpful if you did the same through any proof that you are given. So let's mark it up on the diagram. We are asked to prove that triangle ABF, which is this triangle right here, this smaller triangle, is congruent to triangle EDF, which again is this smaller triangle here. So we really don't have anything to do with anything up here. But the fact that I'm given that this angle and this angle are congruent, but they're not even angles within the two triangles that I'm supposed to prove are congruent, we're going to have to do some special little magic to get this proof done. Let's make a game plan about how we're going to attack this proof. So if we look at the diagram, we have a pair of congruent sides, and I have an angle congruent to another angle. But again, the two angles that I'm given as congruent are not even within the two triangles I'm supposed to prove are congruent. So one of the things that I need to figure out is how am I going to use the fact that these two angles are congruent if they're not even within the two triangles that I'm supposed to prove are congruent. So that's one of the things I need to figure out as I set up this proof. Let's start ruling out the shortcuts that I have available in order to prove the two triangles are congruent. When I look at this diagram, I do clearly see I have two segments that are congruent. I also see that I have vertical angles across from each other within the two triangles that I need to prove are congruent. So I know that vertical angles are congruent. So I have a pair of sides and a pair of angles. So that means I have the shortcuts side, angle, side, angle, or angle, angle, side, since all of those have an angle and a side as part of their shortcut. So again, I have a pair of vertical angles that are congruent. I have a pair of sides that are congruent. Nothing within my given information will allow me to prove that any of the other sides in the triangles are congruent. So I'm going to automatically rule out side, angle, side, because there's no other way that I can prove that another side is congruent to another side within the two triangles. So I'm down to angle, and angle, angle, side. Let's go back to the fact that these two angles are congruent to each other. Way back when, we had a theorem that stated if I have two angles that are supplementary to the same angle or to congruent angles, those two angles are congruent. And if I look at this, I have an angle here, which is within one of the triangles, supplementary to this angle. I have an angle here within one of the triangles that is supplementary to this angle. So I have two angles supplementary to congruent angles. So I know that these two angles are congruent. That was called the congruent supplements theorem. So I would have an angle here congruent to angle here. So there's an angle, a side, and then an angle. So I'm going to hope that I can use angle, side, angle to prove that these two triangles are congruent. So of course, the first thing that we do with any proof is start off with our givens. And then remember, I have a pair of congruent angles that are vertical angles. So let's write that down. I know that this angle is congruent to this angle because they're vertical angles. So angle BFA is congruent to angle DFE. And that is due to the vertical angles congruence theorem. Next, I'm going to use that congruent supplements theorem. But I first need to state that this angle is supplementary to this angle, and this angle is supplementary to this angle. So I have angle ABF is supplementary to angle CBF, that's these two here, and angle EDF supplementary to angle CDF, which is these two here. And again, I've already stated that CBF and CDF are congruent. But first, let's put a reason down. The reason I know these are supplementary because that's the definition of supplementary angles. So again, the congruent supplements theorem states that if I have two angles supplementary to the same angle or to congruent angles, then those two angles are congruent. So again, since I've already stated that CBF and CDF are congruent, I have two angles supplementary to congruent angles. That means that these two angles are congruent. So I can state that angle ABF is congruent to angle EDF because of the congruent supplements theorem. As always, I'm going to mark that in my diagram so I know that this angle 1, 2, 3 is congruent to this angle, 1, 2, 3. So now when I look at my diagram, I have an angle, side, angle situation. Angle, side, angle. So now I am ready to state that triangle ABF is congruent to triangle EDF because of angle, side, angle. My proof is done. Put 2 tick marks to show that. Again, I realize that this proof was difficult, but hopefully you were still able to reason as I did as I went through it. To finish up this section, I provided a screenshot from your book that summarizes all 5 shortcuts that we've seen in this chapter. The first one was side, side, side. If you can show that all 3 sides are congruent, then the 2 triangles are congruent. The next was side, angle, side. So if you can show that 2 sides and the included angle are congruent, then the 2 triangles are congruent. The third shortcut that we saw was called hypotenuse leg. And remember, it was for right triangles only. So within any proof that you're going to use hypotenuse leg, you also have to state that you had right triangles. So if you can show in your right triangle that a hypotenuse is congruent to another hypotenuse and one of the legs is congruent to one of the legs, then the 2 right triangles are congruent. The fourth way that we saw of how to prove that 2 triangles are congruent was angle, side, angle. If 2 angles and the included side are congruent, then you can prove the 2 triangles are congruent. But remember, the side has to be between the 2 pairs of angles that are congruent. And the final way of proving the 2 triangles are congruent was by angle, angle, side. If you can prove that 2 angles and a non-included side are congruent, then the 2 triangles are congruent. So remember, the side that is congruent is outside of the 2 angles that were congruent. These are the 5 ways to prove that 2 triangles are congruent. I would suggest that having this diagram in your notes would be especially helpful for you. So if you would like a copy of it, just ask me and I will get a copy of it for you. But you need to ask first. And that's it for this section. Let me know if you have any questions and we'll figure those out before we move on. And we'll see you then.